Yes, it is a Sunday afternoon and we are all up in here to help you guys prepare for paper number 2. Welcome to the show. My name is Tobile. I just want to send a big shout out to Liberty. Thank you so much once again, guys, for sponsoring the show. Truly, none of this would have happened if you guys were not right behind us. I just want to tell you guys, grade 12s, Liberty has worked really hard to help you guys to sponsor the show. And I must say, I actually see the work that you guys are doing. Now, remember, if you haven't done it yet, please do download the Tenfold education app. That is where you can send through all the questions. So all the questions in today's show, that's where they actually came from the Tenfold education app. So now grade 12, tomorrow you do write paper number 2, and it's all about chemistry. Now, before we answer some questions, I want to just tell you guys a little bit about chemistry. Chemistry is all about having to read your textbook. Most of all the answers in your chemistry paper number 2 is all about the theory that you have actually learned from your textbook. There's not so much calculations as in physics, but there is a lot of theory, meaning a lot of reading. So now if you're somebody who knows how to calculate and you've got paper 1, thumbs up. With chemistry, it's a different ball game. It's all about reading, it's all about analyzing, it's always about saying your statements and proving through theory why something is true or why something is false. Now, most of question paper number 2 does count or does actually contain organic chemistry. So you need to make sure that your organic chemistry is on a thumbs up so that you can actually answer all these questions. And you'll see how each topic actually links from one to the other. So the first question that I'm going to do, we are going to answer simple multiple choice. So I got a lot of DMs saying, oh my word, Miss King, please do help us answer some multiple choice. And I think the biggest mistake which you guys make when you are actually answering multiple choice is that you think you must guess. No. You must actually know why something is true or why something is false. The examiner is just trying to trick you here and there to make sure or to see whether you do actually understand your theory, your concepts, laws, principles, or whatever. So how are we going to answer this question? I'm not going to say this one is the correct one. Instead, we're going to go through all of them, say why something is correct or something is not correct, or have to calculate it first and then prove that the answer is number A, B, C, or D. Another thing that you need to remember, when you are calculating or doing multiple choice, number 1, you must number it correctly. The second thing, you only write the alphabet. You only choose A, B, C, or D. Right? You do not write the whole word. Even though the word is correct, the examiner can really not mark that, right? So please do not make that mistake. Another thing that I've actually picked up what you guys do with multiple choice is that you make the examiner choose. You cannot write A or B or C or D. Even though one of the 2 is correct, the examiner cannot mark that right. Usually they say there is only one possible answer. So you must make sure that you only choose one and you do not make the examiner choose. Okay, without wasting any more time, let's answer some paper number 2. So the first one is multiple choice questions. So it reads as follows. It says 4 options are given as possible answers to the following questions. Each question has only one correct answer. We must write down the letter A to D, A, B, C, or D, meaning next to the questions numbered in the answer book that is provided to you. Now let's look at the first one. We must consider the structural formula of the organic compound below. Before we answer this question, I want to take you back. In the start of organic chemistry, we learned about functional groups, we learned about the homologous series groups, and all that stuff. What did this teach us? It taught us that certain organic molecules can actually be identified with what they have. For example, if you only have a single chains, alkanes, double bonds, alkenes, triple bonds, alcohols, carboxylic acids, and so forth. So all of those different organic compounds can be identified with what they have. In this one, they have given us the structure. We now need to go see what does it represent and then go choose the correct answer. So let's start with the structure first. I see that my structure has got a double bond O at the end. So we know that we've got carboxylic acids with a double bond O. We also have alcohols, not with a double bond O, but with an OH. We also have an ester. We've got aldehydes, and then we've got ketones. So now the question here says, which of the following is the correct IUPAC name of this compound? I just want to stress this. This is an acronym that we use in chemistry and applied chemistry to name organic molecules. I would also say you must know the full name for this acronym. Now I can see here that it's represented by having a double bond O at the end, right? That is how I identify this organic molecule. Let's see the options that I have. The first one is ethanone. Now, looking at the name ending, I can see that this is a ketone. This is a ketone, and a ketone is a C, 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 and a double bond O between the C's. Ethene means that there is a double bond, right? But it does not tell me the double bond on the O. We've got ethanol, which is an alcohol. This just means there's a C with an OH. And then we've got an aldehyde. An aldehyde has got a C with a double bond O on the last carbon, which means this is a C with a double bond O on the last carbon. It cannot be a ketone because this O is in the center of that C. This one's out. It cannot be ethene. Ethene just tells me that it belongs to alkenes, which only have double bonds. Ethanol is an alcohol with an OH. However, the O to the carbon is not a double bond, but a single bond, whereas here we need a double bond. Number D, we've got ethanol, meaning that it is an aldehyde with a double bond to the last carbon. So my 1.1 answer is number D. So let's look at what number 2 has for us. So here they're telling us which of the following represents a balanced, very crucial in chemistry. You need to know how to balance equation, and that is grade 10. A balanced equation for the combustion. Remember, if something goes through combustion or the reaction of combustion, we have two products that will form. We have CO2 and then we've got H2O. And this is the combustion of octane. Now, from organic chemistry, we learned that oct means I'm going to have 8 carbons in a chain, and then it's going to go through combustion. Now, I want to stress the different types of reactions. Now, remember, going back to organic chemistry, there are different reactions that take place that we need to know what are the products that form. For an example, some products can go through addition, substitution, elimination, dehydration, and so forth. So with some certain reactions, we know that water is a byproduct or carbon dioxide is a byproduct. So the examiner just told you combustion, but you needed to have known that the reaction of combustion actually produces carbon dioxide and then water. And then they further spice it up to say a balanced equation. This is what I would do. I would write down octane, take it through combustion, remember it's with oxygen, and balance it and see which one actually works. So let's do it. So I'm going to do it here. So I'm going to do it here at the bottom. Remember, combustion of octane. Oct means 8 carbons. I'm not going to write the whole thing because I don't have space. I'm just going to use the molecular formula. It will be CH18. Remember, combustion is through oxygen. Oxygen will be O2. Remember, oxygen is a diatomic gas, so you'll never find it floating by itself. It'll always be O2. The combustion of anything will always produce CO2 plus H2O. Now remember, the examiner did stress about it being balanced. I'm just going to go through the balancing and then I'm going to give you the balanced numbers. I've got 8 C's on this side. I've got only 1 on this side. I've got 18 H's on this side. I only have 2 on this side. I've got 2 oxygens on this side and I've got 3 on this side, which means it's not balanced. Remember, it must be balanced. Left-hand side must equal the right-hand side. If I put a 2 there, if I put a 25 here, if I put a 16 here, and if I put an 18 here, it's balanced. For my C's, I've got 2 times 8 will give me 16. I also have 16 on this side. 2 times 18 will give me 36. I've got 18 times 2, which also gives me 36 on this side. 25 times 2 will give me 50 on this side. 16 times 2 plus 18 on this side. Then it is then balanced, which means that my first one, let's see. This one is not balanced. I've got 8, 18 H's on this side. Nope, not on that side. This one is not balanced. My O's, I've got 2. I've only got 3 on this side. That one's definitely out. I've got 32 times 2 on this side, but 8 times 2, definitely not balanced. Let's look at this one. This one's also not balanced. I've got 16 oxygens and 16 times 2 plus 9, definitely not balanced. The only one that is balanced, 2, 25, 16, and 18, is then number A. The only way you could have gotten this right is if you actually worked it out here through the combustion of octane, balanced it, and then you could have chosen. It is not a guessing game. Remember that. Let's look at number 3. The question says, which of the following compounds will decolorize bromine water the fastest under normal conditions? Now, there's certain reactions again. Let's go back to what we know from different types of reactions. Certain reactions will change color. Certain reactions will form a precipitate and things like that. The back of our minds, we know when all of these things are actually forming and happening, it's either we are breaking double bonds or we are making double bonds. Now we need to look at the different options that we are given and what will then decolorize bromine water. Remember, if you have to decolorize bromine water, we have to be breaking bonds and making them single bonds, and then the color of bromine water will then change. So what I'm saying is that we need to either have an alkene or an alkyne, a double bond or a triple bond for it to decolorize. So let's look at the options that we have. I'm going to start at the bottom and move up. So the first one that I have is ethane. The name ending of ethane, from what I know from my functional groups, is that it just means there is single chains. Number C is ethanol, which is an alcohol, which just means it is a C attached to an OH somewhere. B, let me just not write the C, let me just write the functional group. OH, just to make it easier, this is single chains. Ethanol will have the C with a double bond O. And then we've got ethene. Aha, ethene means there is a double bond. Remember, in contact with bromine water, if ethene is in contact with bromine water, it undergoes an addition reaction. An addition reaction means that the ethene will break the bonds, however, which means that ethane cannot do that. All of these only have single chains or single bonds, but ethene has got double bonds. It will undergo an addition reaction and therefore will decolorize the bromine water. So B, C, and D are completely out. And the correct answer for this one will then be A. Let's look at the next question. So here we are told we have 3 catalysts. Now, I love going or reading through question papers and then looking at some of the terminology that might come about. I want to talk about catalysts. Remember, when we talk about catalysts, we talk about substances that take part in a reaction by speeding up the reaction rate, by lowering the activation energy, but with actually not undergoing any chemical change. That's what a catalyst does. Let's make an example. If you are having a braai, but the fire is just taking too long, right, and it's not working, then you put some fire lighter, right, and then the fire all of a sudden speeds up. Right? It acts as a catalyst, but when you eat your meat, it doesn't really taste like firelighters. The firelighters only acted as a catalyst. It sped up the reaction rate by lowering the activation energy, but without actually undergoing any chemical change. So that's what the question's all about, catalyst. So we know the reaction rate was completely fast. So we've got 3 catalysts which are used separately to increase the rate of a hypothetical reaction. When you see this word hypothetical, it just means something that was made up or something that was used to explain something else. The rate of a hypothetical reaction, in the diagram below, we've got E1, E2, and E3, which represents the effect of each catalyst on the activation energy. Remember, activation energy is the minimum energy required for a reaction to take place. Now, most of the time when we see activation energy, remember when we did exothermic and we did endothermic graphs and when we were able to identify the activated complex and all that stuff. So now this is a different graph. Most of the time it's exothermic, endothermic. This one is the Maxwell-Boltzmann distribution curve. So using the Maxwell-Boltzmann distribution curves, we have the number of molecules on this side, and then we have the kinetic energy of the molecules. Remember, this is within temperature. So now let's see. The question says, which of the following is the activation energy for the reaction with the highest rate? Now remember, when you're looking at this graph, you must remember that the first part of this graph will therefore be the highest, right? Which means this will then be C1. Because as it moves further, it makes it more incorrect. That is the activation energy for the reaction with the highest rate. This one was pretty an easy one. Let's look at number 1.5. So I already see calculations and thinking here. So I've got 50 cubic centimeters, which is volume, of 0.1 mole per cubic decimeter, which is my concentration, solution of hydrochloric acid, which is poured onto 5 grams of granulated zinc. Just already by seeing the word granulated, I know when we talk about reactions and stuff like that, and we talk about the surface area of certain reactions, granulated, lumps, powder, liquid, and all that stuff, it means that it has to do with the rate of a reaction. The rate of the reaction either being slower or the rate of the reaction either being faster. So we're using granulated zinc, which is inside a glass beaker at room temperature. They're asking us, which of the following factors, now there's various factors that we need to know, will not. Which one will not increase the initial rate of a reaction? Remember, the rate of a reaction is the decrease of the reactants and so forth. So I want to talk about the factors. I want to take it back a little bit. When we talk about concentration, if we have something that is more concentrated and something that is diluted, the concentrated one will speed up the reaction rate. I think an easy way for you to actually understand concentration, if something is concentrated, you've got many soldiers. These soldiers are working day and night to do something. If something is diluted, not so many soldiers, right? Here and there, don't work so fast and so forth. If something has a high concentration, fast reaction rate. Let's talk about surface area. If for example, if me and Tebogo are doing an experiment, and Tebogo decides, oh my word tops, I'm going to use a solid. And I decide, I'm going to take the solid, but I'm going to make it into fine powder. And we both do a reaction. The reaction where we used fine powder will be much more quicker, or a quicker reaction rate than the one with a solid. Let's make a normal example in our ordinary day lives. If you have a headache and it's pounding, you're more likely to drink the headache tablets that is a powder form than in a solid form. Because in a powder form, it will dissolve much more quicker and get into action much more quicker. It's the same thing with temperature. If we have a reaction rate where we're using a high temperature or we're using a low temperature, then the reaction rates will not be the same. Let's make an example in our everyday lives. Let's say me and Andile are deciding we are going to cook pap. And we have the same pots, same amount of water, same amount of maize meal. But I am in a hurry and I put the plate on 7. And then Andile decides she's got a lot of time to wait and she puts the plate on 1. Obviously, my pot is going to boil much more quicker and I'm going to cook much more faster. High temperatures, faster reaction rates. So if ever you get a question like this, I want you to think about all the factors. It's also nice to have a story behind every factor so that you can actually remember it as you move along. So now, which of the new factors will not increase the reaction rate from what we've just said? Let's go through these ones and see which one's the correct one. So 1.5, I am told, grinding the granules into a powder, granulated zinc, will not increase. No, grinding the powders will definitely increase it. We're looking for the one that will not. If we are using 30 cubic centimeters, so like check, the volume here was 50, and then if we use 30 cubic centimeters with a concentration of 0.2, definitely. Remember, if you decrease the volume and you increase the concentration, that will definitely, at room temperature, it still will. If you increase the temperature of the acid solution to 50 and increase in temperature, increases the reaction rate. We're still looking for which one will not. If you are using, so if you just increase the volume that you have from 50 to 100 and you keep the concentration the same of the hydrochloric acid at room temperature, if you just use a bigger beaker, same concentration, it will not increase the rate of the reaction. It's just like making a cup of tea in a bigger cup. That's technically what it means. Let's look at number 6. Now we have a lot of graphs here. Remember, every time you're given a graph or a diagram, you always answer from that. 1.6 says, the graph below represents the change, I love that word, in the rate of reaction versus time for the reversible reaction that took place when an amount of hydrogen gas and iodine gas was sealed in a container. The equation for the reaction is as followed, and I can see that the equation is balanced and it's all in gaseous forms. Now, this is some information that we're given here. Remember, delta H is heat enthalpy, and it is smaller than 0, right? Making it an exothermic reaction, meaning that heat was then released. Equilibrium was first established after 5 minutes. So now this is the graph that we are given. Now remember, guys, if ever you are looking at a graph, right, you will see that the one part will be going up and the one part will be going down. Every time you are reading a graph, especially when we're talking about reactions, you must already go back to the equation that you're given and think, in a reaction, my reactants will get less because I'm making products, and my products will get more and more and more and more. So when you are reading, if you need to, put some numbers on your graph and then start reading off that graph. This is what I mean. Here, I can see that this started at 0 somewhere, and this already had a number, hypothetically speaking. So this was getting used up the solid line, the dotted line was then actually making something. It started off at 0, but it was making something as it went apart. Between 5 and 10 minutes, we had equilibrium. How do I know this? Because it is a straight line, no curves, no spikes, nothing. And then something happened here at 10, and then again, the solid and the dotted line moved together. So that's already telling me something. So now let's read what the question says. What change in the conditions was made at 10 minutes to change the rate of the reaction as indicated in the graph? Something you have to keep note of is that when both the solid and the dotted line move together, that it means that a catalyst must have been used. So I can already see a catalyst was used. Remember, catalysts are substances that speed up the reaction rate by lowering the activation energy without undergoing any chemical change. So that's a catalyst. Let us see why all the others are not correct. Temperature was increased. Remember, if you increase temperature in a reaction rate, it decreases the equilibrium constant. If we decrease temperature, it causes the equilibrium to favor the exothermic reaction. It will favor the exothermic reaction. Remember what I said, this is some information that we were given. So that is again not true. And the external pressure of the reaction was then decreased. That means pressure was decreased. That is not true. A catalyst was then added because the solid and the dotted line move together. So that is why this answer is then number A. Let's look at number 1.7. We must consider 4 different solutions. Which of these solutions is a dilute, weak acid solution? Right, so remember we do get strong corrosive acids, but which one is a weak acid? So here we've got 0.1 mole cubic decimeter of HCl solution. Okay, I can see that is there, but HCl is a strong. The question said dilute weak acid. Let's move on to the next one. We've got 5 mole per cubic decimeter. This is a weak acid. Number C, 0.5 oxalic acid. That is correct. NaOH is a base, so D is out. So my options is between B and C. Now let's look at weak. Here I've got a concentration of 5, where number C, I've got a concentration of 0.5. Think about my soldiers. Got a lot of soldiers working here at B and not so many soldiers working here at C. They are both weak acids, but the concentration of these solutions will tell me which one is then weak and not. Then this one will then, number 1.7 will then be C. That is the weak acid for the solution. Number 1.8, we have the following equation represents 2 hypothetical half reactions. Remember, when you talk half reactions, you must think galvanic cells, voltaic cells, and all that. The reduction potentials are also provided, right? It's hypothetical, so this means it's something you will not find on your 4B standard table. However, you need to know oxidation, reduction, and so forth so that you know what happened. So I can see I've got x2 plus 2 already. If it's on this side, it gained. I can see it's a negative. Initially, it was a 0. It became a 0. It became a negative here, so it gained electrons. Reduction happened. And then I've got my y here. I can see I've got a positive, and then I also have a negative. So the question says, which one of the following substances from these hypothetical half reactions will be the strongest oxidizing agent? Now remember, I just want to take it a little bit further. We use oil, rig, and we use red cat. Next to this one, I just want to write an ox. So oxidation is the loss of electrons, where reduction is the gaining of electrons. Just taking it further, reduction happens at the cathode. At the anode, we have oxidation, right? At the anode where we have oxidation, we've got a reducing agent. At the cathode where we have got reduction, we've got an oxidizing agent, right? So you need to know, what does oxidation mean? What does reduction mean? Where does it take place? And from there, you'll know which was what agent. By mere looking of these two, when they say, which one will be the strongest oxidizing agent between the two, I can already see what happened between these two, which one lost, which one gained, and from the positive to the negative, from my rules of physics, I can see that my X2 is the one that will be my strongest oxidizing agent from the theory I know of oil rig. Let's look at number 1.9. Number 1.9 says, which of the following combinations correctly shows products formed during the electrolysis of brine? Now remember, when we talk about brine, it's just the manufacturing of salt, right? So now let's see what is going to happen. I'm going to start from the bottom and I'm going to work up from it. We've got hydrogen, we've got chlorine, and the anode, I've got oxygen, hydrogen, hydrogen, oxygen, chlorine, hydrogen. Now, if you are just reading through this and you do not know the electrolysis of brine and you do not know the graph or the diagram of it, you will not get it right. I want to take this a little further and I want to actually explain what happens. So we use a structure that looks like this. Unfortunately, these are one of the structures that you need to know. We use a structure that looks like this. It goes all the way down. So what happens is they insert brine on the side, which is NaCl. And then we have rods on both sides like this. I can say this is my positive rod and this is then my negative. What happens is when the brine comes through, we will eliminate Cl2 gas at the top. I will have H2O water that moves through this side. I'm also going to have H2O on that side, and then I'm going to have OH minus on this side as well. The Na from the brine will also move as an Na positive and move through on that side. I will then again get brine on this side. What will come through here is hydrogen gas. Is then hydrogen gas, right? And then again, you need to know red cat. You need to know anox. Reduction happens at the cathode, and by the anode, then we have oxidation, which means by my anode, I will have my chlorine gas, and by my cathode, I'm going to have my hydrogen gas. Here's my hydrogen gas, here's my chlorine gas. And this structure is in most textbooks that I've seen. You just need to know the structure, that brine will come in on one side, in which side the chlorine gas and the hydrogen gas will be ejected, and then identifying in which of those, where these two gases actually come from. Is it from the anode or is it from the cathode? So based on this, I've got chlorine, I've got hydrogen gas. Let's see which one is then the correct one. Let me just take this down. I can already see that at my anode, I had my chlorine, and at my cathode, I had my hydrogen gas. Oxygen is definitely out, nothing like that. All option A, B, and D could have been possibilities, but we needed to know what was happening at the anode and at the cathode. So number 1.9 will then be an A. You needed to know your rules of electrochemistry before you could answer that question. Let's look at 1.10. It says we must study the diagram below illustrating the industrial production of product number C. So I've got NH3, I've got O2, and I can see a lot of things are going through there. Now, one thing that you need to keep in mind when we're talking about industrial procedures and so forth, you need to know what processes there are and what they actually produce. For an example, like the Haber process, how sulfuric acid is formed and so forth. Unfortunately, that is a lot of reading. You need to know most of those steps off by heart, and as you practice it, you actually do get better at it. Another thing that you will see is that as you keep writing it, going through it, practicing, you will see the common trend that actually happens. They love asking a question like this where they give you an A or a B, different alphabets, and you have to put in the missing words or the missing molecules. Now, let's look at this one. So this one says, which process is used to produce C? So C is right here at the end. I see I've got NH3, so I know that then must be the Ostwald process. There are various ways that you can actually remember it. There's a few that I've shown you in previous shows. So let's look at this one, fractional distillation of air. Nah, this one is out because this is just carbon becoming a solid and it becomes cooler in air. We've got the oxidation of ammonia. No, this one is definitely out. This is a fundamental co-process in the global biochemical nitrogen cycle. Let's look at the Haber process. This one looks a bit interesting. But no, remember when we talk about the Haber process, we talk about the production of ammonia from nitrogen and hydrogen. The Ostwald process is then the correct one because then we have nitric acid. So you could have only known that if you knew what different industrial processes actually do produce. So that is one of the ways that you can do multiple choice. It is not a guessing game. You have to have a reason why something is true and have a reason why something is not true. You cannot guess it. And I always say, once you have chosen the answer, go back to see if it actually matches what the question is actually asked. Another crucial thing with multiple choice is that most of them actually count between 2 and 3 marks. I mean, if it's out of 10, out of 3 marks, you already have 30. That is not a good one. So make sure that you read, you practice, and you analyze everything before you find your correct answer. I think let's go for a quick ad break, and when we come back, we will do a little bit more on paper number 2 revision.